Hello there, CP Finite Mathematics. Welcome to lesson 2.1. We are getting into systems of equations, and today we're going to be solving them by graphing. Okay, it's our first method to solve them. Graphing calculator can be helpful, and we'll just get on into these new problems. So some new terminology and types of systems. First off, a system of equations simply is just two or more equations. So two plus equations, two or more at one time. We're eventually going to solve systems of three equations, and that'll just be a blast. Can't wait for those. So for two or more equations, a dependent system, what we call a dependent system, that is a system that has infinite solutions. Infinite solutions. Okay, so we'll see what that looks like. A consistent system, that is a system that has at least one solution, or a system that has one solution. That has one solution. Okay, dependent, they have infinite solutions. And consistent is a system that has one solution. Okay, let's get into some practice then. So simply put, solving by graphing. Hopefully your graphing skills are up to date. Some different ways you can do these. If you want to put things into y equals, that can be helpful. So if we solve this first equation, negative 3y equals negative x minus 18. And if you divide everything by negative 3, we would have 1/3 x plus 6. Okay, I will choose, and you can use different colors for these graphs. That's what kind of makes it nice. And this will be our red equation. So y-intercept at positive 6, a positive 1/3 slope, up 1 over 3. And that should be a skill you remember. And you can always use your graphing calculator as well. That's why I have it here. But hopefully that type of graph is pretty easy. So you graph time, okay? And this should be pretty much, you should have learned this in Algebra 1 or 2. And then we'll focus on the second equation. The second equation, I'll show you another method. In our last session of notes, our last unit, we talked about the x and y chart in which you can find the intercepts. So if I plug 0 in for x, it's really negative y equals 4, which means my y is going to be negative 4 because I would divide by negative 1. If I plug in 0 for y, it's just going to be 4 divided by 2, which is 2. You can certainly have solved it into y equals, but just another skill for you to do. So I have the point 0, negative 4, down to negative 4. And I also have the point over 2 to 0. Okay, this will be our blue equation. So the blue equation here, I can see it has a slope 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2. And basically, we're just going to keep plotting and graph that one. And hey, look at that. Notice they intersect one another. Boom, right there. So that is the solution. Okay, so the solution, and as a coordinate pair, it would be 6, 8. 6, 8. Now, the last little thing, since this has a solution, we would call this a consistent system. So it's a consistent system. So the last little thing. All right, so basically just graphing two things at a time and seeing where they intersect. Another example, if you want to pause and try this one out, it's already in slope-intercept form. So pause, try it, and check to see if you get the same thing. Negative 2x minus 7, I'll let that be my red equation. Down 7, and a slope of negative 2, 1, 2 over 1, 1, 2 over 1. be careful with negative slopes. So careful, negative slopes always, not always, but tend to throw students off. So if you are one of those students, be careful with negative slopes. Connect them the best you can. If you have a ruler at home, that's going to be very helpful. And most of the time, they should intersect at a nice, a nice point for you. Blue graph, it'll be up 8, down 1 over 8. 1, 2, 3, 4, 5, 6, 7, 8. Up 1 over 8. 1, 2, 3, 4, 5, 6, 7, 8. And yes, they do intersect there. I'm a little off on my first line. But that there is what it should look like. Okay? So this solution is at -8 and 9. Again, it has a solution, just one, so we call it consistent. So it's a consistent system. Alrighty, hopefully you're getting the hang of that then. Let's see what some of the extra tricky ones look like. Okay, so 3. Notice this is all messed up, so really just get it into a form you're comfortable with. We have x on the right, y on the left. I'll just solve it for y by subtracting the 18, so -3y equals -5x minus 18, and divided by -3. So the first equation is y equals 5/3 x, and then plus 6. Okay, let's see what this equation is going to be. So 5x plus 27 equals 3y. Solve it for y. So really I could just divide everything by 3. How nice is that? And that means y is equal to 5/3 x plus 9. Now, something should be going off in your head, idea-wise. 5/3, we have the same slope in a different y-intercept. So these lines are going to be parallel, okay? So let's just notice what that means as far as solutions here. Still want to graph them. 5/3 x plus 6. And we go up 5. Whoop, we're running out of space, so we'll go down 5. And to the left 3. And 1, 2, 3, 4, 5. Okay, and we'll connect those the best you can. And then we'll also graph the other equation up 9, and it has the same slope. 1, 2, 3, 4, 5. 1, 2. And they're very close, but notice they are never going to intersect one another, hence why they're parallel lines. If they don't intersect, this is an example of no solution, okay? And just like consistent and independent, we actually would call this then inconsistent. Okay, if there is not a solution, it is inconsistent. That's not consistent with what a system is. So make sure you keep note of that vocab word. I didn't list it up above because we learned it right now. So no solution really just means the same thing as inconsistent. And let's look at what the last type would be if it's a dependent system. So again, solve for things, make them something you're comfortable with. 3y equals positive 3x plus 9. And if we divide by 3, that just means it's x plus 3. And notice it's written a little differently. But hey, these two equations are exactly the same. Okay, y equals x plus 3. 3 plus x equals y. And all that means is that this is going to be our infinite solutions or dependent system. So dependent. Okay. Again, let's graph it. Pretty easy graph there, hopefully. Slope of 1 over 1, intercept at 3. Okay, so that is basic systems of equations. Okay, you can certainly pause here. That was the main skill.